Okay. So for the next part of your physical properties chapter itself, we're going to learn about physical quantities and units itself. Now, if we look at the word quantities itself, is basically how do we measure? Because previously we talked about the chapter on the physical properties. We have all your different properties such as your your strengths, your hardness, and all that. So the thing is, how do we know if something is hard? How do we know something is strong? How do we know if something is long? How do we know what is what? So because if we just describe it briefly in words, it's a bit vague. So if you notice over here, he said short period of time, took a bit longer. So now the question is, how short is that short period of time? Is it 1 second? Is it 2 seconds? How short is that short? So if you only say short period of time, it's very difficult for us to judge if this person is fast or slow. So the thing is, we will actually use numbers and units to represent what they are. So similarly, you can see it took a bit longer, right? So we know that Peter took 22.5 seconds. So what is that a little bit longer? So the a bit longer will be the difference in time, which is 22 minus 22.0. So we know that it took 0.5 seconds longer compared to John. So you can see with numbers itself, it's much easier and to show a clearer picture on who is faster and who is slow and by how much. Because if you only say if you just briefly mention it in words, it's very difficult. So the thing is, for quantities, we always use magnitude and the unit. So what exactly is the magnitude? Magnitude is the how much, is the number, the value. So if you see over here, for example, the one that they used was time. So instead, let's use length. So if I say the length of a ruler is 15.0, this number is my magnitude, which is basically the value, right? And this is my unit. So the length here is your quantity. Okay, so you can see over here is quite a straightforward one. So the thing is, there's multiple units in the world. So which one do we use? Why do we use seconds for time? Why do we use cm or meters for your length itself? We have something what we call a SI units. These are a set of units that is a standard units used. So basically, throughout the world, all scientists agree to use this for all their papers because this set of units, these SI units, are this group of units that is all the scientists agreed to use so that there is no confusion when they are writing their papers itself. Because the most common one that have a very difference is temperature. Now, in Singapore, we use degree Celsius, right? And in America, they use degree Fahrenheit. So to avoid them fighting itself, they actually use Kelvin, which is actually a unit that is agreed upon, and you can easily convert from Kelvin to Fahrenheit and from Kelvin to degree Celsius. It's much easier compared to degree Celsius and Fahrenheit. So it's a more common unit that they all use. Okay. Now, so typically for your current level at lower set, we only learn about length, mass, and time. Okay, so depending on the other chapter, this current is your electric current. So we'll learn it during your electric chapter, and your temperature is linked to your heat. So we'll learn it during your heat chapter itself. So for the other two itself, it's not so common. This one is actually under your chemistry part. So take note when you are starting to learn about your chemistry, then you'll learn more about this part. Okay, so basically length, mass, and time. Now, I want you to take note of mass. Sorry, mass is the only one that actually has an extra word in front because this is actually in kilogram. You will notice that in front of the rest, there's nothing in front, right? Only that your kilogram has this extra kilo in front. Kilo is what we call a prefix, and I'll touch more about the prefix later on. You'll notice that for most, if not almost all of the SI units, all of them are mostly single digit. So if you have more than multiple letters in front, most of the time this is what we call a prefix. So we don't actually consider that part as your SI units, except for mass, we use kilograms. Everyone else should not have any kind of extra letter in front of it. Okay? So take note, this is what we call your base quantity or your basic quantities, because every other unit is actually just a combination of all of this. So for example, area is length and breadth, correct? So what is length and breadth? It's actually length and length. So you can see the units is meters times meter. So you get square meter or meter square. So you can see this is actually just meters times meters. So basically every other unit is actually just a combination of these few units that we learn. Okay, and sometimes you might see special units later in the years. You'll see newtons, you see pascals, you see volts. Those are actually the name of scientists in the past. And to commemorate them, we actually use the unit to represent force, for example. So it's like, for example, your force, hang on, your force be, let's say, 200 newtons. So what exactly is this newton over here? This is actually kg meter per second square. But this one you don't need to know, but basically, right, instead of writing this very long thing, we just use newtons instead. It's basically to make us write things clearer so that you don't have a lot of all these messy units itself. So you can see actually this set of units, even though they are single letters-ish, you can see that they are actually still a combination of the basic quantities that we have on. Because of this, these are still considered derived quantities. So don't need to worry too much about this. The one that you need to focus on is actually just this over here. Okay, so you need to be familiar with your meters, kilograms, and seconds. Because whenever we want to calculate anything or using formulas, we try our best to always convert them back to SI units first before we use the formula to avoid making any kind of careless mistakes. Now, previously, just now I mentioned about your kilo being a prefix, right? So if you notice over here, prefix, pre means before. So before the unit. So if you combine it, basically it just means before unit. Okay, so these prefixes are actually just a multiplier. So for example, if you see on your right hand side, this 0.8 picometer, basically it means I have 0.8. Pico, the P here, means times 10 to the power of minus 12 meters. So this P that you see here is actually this times 10 to the power of minus 12. So every time you have a prefix in front of your unit, it doesn't have to be meters. It can be some, for example, the common one. Now, 1 milliliter. What is that? Milli, if you look at the table, milli is 10 to the power of minus 3. So this is 1 times 10 to the power of minus 3 liters. So if you see this and this, they are actually exactly the same. Okay? So if you want to do the opposite, how much is 1 liter? How many milliliters is 1 liter? Basically, we'll actually work the opposite if you just divide both sides by, okay, hang on. So instead of times here, because, wait, let me think of a way to put it across to you. Now, if you have prefix, multiply. Okay, so let's say now 1 liter. You want to change to milliliter. Okay, so on this side, you don't have the prefix. Okay, don't have, then we will divide. So instead of times, we will now divide by the same value, 10 to the power minus 3. You press this in your calculator itself, this is actually 1000, which makes sense, right? Because 1 liter is 1000 milliliter. Now, if your school doesn't teach you this weird phrasing, this 10 to the power something, you can actually just remember 1 liter is 1000 milliliter. So if you want 1 milliliter to liters, you divide by 1000. You do the same over here, you also divide by 1000. So basically for almost all of them, all of these in lower secondary, most of the time we are just using this form. Okay, so for the rest, unless your school mentions it, especially for the IP schools, then for the normal schools itself, you all just need to remember this form. Okay, so out of these four, the only one that is new to us is probably your DESI. Okay, this one is not as commonly tested, but you should know that DESI is -1. Okay, so similarly, if you actually notice, this is actually 3, 6, 9, 12, minus, 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 minus. This is 3, 6, 9, 12, plus, 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 plus. So the thing is, if you were to notice, most of the letters that are in capital are positive. Most of the letters that are small letters are negative. Okay, but the only exception is your kilo itself. So kilo is one of the more special one. So small k is +3. So 10 to the power 3 or 1000. Okay, so just be careful of this. If not, you all can actually write down that this, basically you see 10 to the power 12, right? You have 12 zeros at the back. So a lot of zeros. So the common one is 1000 here. This one is 1/10. This one is 1/100. This is over 1,000. Okay, so you can see that these are all your different values. That's what they mean. These two are equals the same. Okay, so if you all don't remember what is this 10 to the power something, you can remember it this way as well. Okay, so let's take a look at some of the examples. So first thing, you have the prefix. I have the prefix. I will times. Okay, so 65 millivolts. Now, if you notice the units at the back, they don't matter. We are interested in your calculation over here. So you just keep the V as it is. You don't do anything to it. So 65, you see the word milli. I have the prefix. I will times. And milli itself is -3. So the volts will just be as it is. So this is the same as your word, your letter M. Okay, so you just press this in your calculator itself. 1, 2, 3, 0.065 volts. Okay, so just take note, if for those who don't have a calculator, your decimal place is here, you jump 3 times 1, 2, 3. So it's 0.065. Okay, next, let's talk about if you don't have the prefix. Okay, so this weird letter over here that you see down here, this is what we call micro. Now, how do we draw micro? Typically, we write U. U looks like this, right? So what you want to do is straight line down, go back up, and then write your U. This is what we call micro. Because if you just tilt your head slightly, it kind of looks like a very cursive M, right? So the thing is, it looks something like that. So that's why you use it as a letter micro. It's actually a Greek letter. So the thing is, we don't have the prefix. The prefix is on the other side. So we don't have, we will divide. So divide by how much? Micro is something new. So let's use the table. It's -6. So we divide by -6. So you actually end up with a very large number over here. Okay, so unfortunately, because we're dealing with this kind of weird looking number, we will just press the calculator to make things simpler. Because we're in secondary school, do remember to bring all your calculators to school. Otherwise, you have a lot of trouble with this kind of very large calculations. Okay, so just remember, you have, you multiply. Okay, the split on the side that you have, on the left-hand side, typically, you will multiply. If you don't have it, you divide it by it. So instead of, if you have, you times, don't have, you divide. Okay, so over here, let's try to do some of your examples. 450 micrometer. So I have the prefix, I will times. Micro is a small letter, so we put minus, and micro is actually 6. So meters over here. So you can see it's very, very important for you to actually jot down the units, because the units is actually telling you, or actually your step that tells you what to do. 3, 0.00045. Okay, so let's just double check using the calculator. Okay, now even though you do end up with a fraction, we don't write fractions for science. So for science, we try our best to write the decimal place. Okay, so next one. Second one over here, 680 decimeter. I have the prefix, so I will times. So deci, small letter minus, and deci is 1. To end up with 68.0 meters. Okay. And last but not least, your 0.45 grams. Now, because we don't have the prefix, we will divide. Divide by milli, small letter, and milli is 3 grams. So because of this, we will actually end up with 450 milligrams. Oops, I forgot to write. That's why you can see it's very, very important for you to write the prefix. Because if you don't write the prefix, you actually minus 1 mark for not writing the correct units. So please be very, very careful about this. Don't lose marks because of all these small little mistakes. So make sure to write your units clearly so that the teacher knows what's going on. Okay? And for those who have very untidy handwriting, try your best to write nicer, because there have been cases where even your upper sec seniors, they also make the same mistake where they actually use, they write so, their handwriting is so untidy that they actually use the wrong number for their own calculator when they write it themselves. So please be very, very careful about this. Now, next one. Sometimes, most of the time, you'll be dealing with word problems like this, kind of like for math as well, right? So first thing, we haven't learned about speed. So I'll write down the formula for you. This is your total distance over your total time. So every time you have a formula, something like this that we learn, right? The first thing we do is not to jump straight into the question. The first thing that you actually want to do is to write down the individual components first. What's your distance traveled? They tell you you traveled 1.61 kilometers. Now, if this question asks us to write it in your SI units or to write it in their correct units, right? Kilometers, because of that K in front, this is not SI unit. Okay, this is not SI unit. So we want to change it to SI unit. So 1.61, I have the prefix L times 10 to the power 3 meters. So I end up with 1610 meters. Okay, so you do the same for your time as well, total time. So total time itself is 154, and this is microsecond. I have the prefix, same thing, L times, and micro is a small, so and it's 6 seconds. So you actually end up with 0.123154 seconds. Okay, so after we solve this, then we go back to your formula that we put in the values that we just found. 1610, 0.123154. So if you press this number into your calculator, 0.000154. So you can see over here, my handwriting is very ugly. So I'm going to erase it and write it properly to avoid making mistakes. So you end up with a very, very large number. 104545. Hang on, 1, 2, 3, 4, 5, 6, 4, 5.45. A very, very large number, right? Now, we don't write our final answers as this very, very long version. Before we move on, this is in meters, this is in seconds, right? So we get meters per second. So this per is just the divide sign. Okay? So how do we write this properly? Now, basically for most schools, you will actually round it up to 3SF. So what do we mean by 3 significant figures? So 3SF refers to 3 significant figures. Basically, we start from your first, we start from your first non-zero digit. We will write 1, 0, and 4 is our third digit, right? But we look at the fourth number. Now, this number, if it's 5 or more, we're going to round up this number. Okay, so because of this, this will be considered round up as 3 significant figures, because you look at your first 3 digits over here, and we look at your first 3 digits over here. Because the fourth digit is 5 or more, we will round it up. So this value is just an estimation for your very, very long decimal over here. Because typically for final answers, we try to round it up to 3SF if it's very, very long or very, very small. So like 0.0000 something, we try to round it up to 3SF as well. But take note, we must start from a non-zero digit. So we must start from 1. Okay, so don't worry about this one too much. Later I'll talk more about this, but just need to know if you have a very, very long number, we don't leave it in the fraction. We will try to put it in decimal and basically try to whole number it to a cleaner round up version. Okay, so the thing is, why are we using all your prefixes? Why are we using all your values over here? Because when you write the prefix, right, it looks very clean. 450 micrometer, instead of writing so many zeros that is very, very confusing, just simply writing this makes it very easy for the person to understand, oh, 450 micrometer is actually a very small meters, but it's an easy way to demonstrate your numbers. Okay? Then next, this is your second method to write very large numbers or very small numbers itself. Now, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's say our length is this number. How, if we write this, not wrong, but basically, because this number is very, very long, it's very, very hard to write, you don't want to use your prefixes, you can actually use, basically, the decimal place is over here, correct? So 1, 2, 3, 4, 5, 6, 7, 8 over here. So if we move your decimal point to here, by right, which we have 1.2345678 all the way, right? So instead of this, we would pick the first 3 digits times 10 to the power of, so same thing, we actually round it off to 3SF. We will look at the number on the fourth one is less than 5, so we do not round up. And how many times did we jump? 1, 2, 3, 4, 5, 6, 7, 8. We jump 8 times, so this will be 1.23 times 10 to the power 8 meters. And don't forget, because we rounded it up, it will be 3SF. Okay, so this is what we call a standard form. Now, your standard form itself, basically, it has to be in terms of in this format over here. Okay, so A must be greater than 1 or less than 10. So it can only be 1, 2, all the way till 9. It cannot be 10. Okay, so if you notice over here, you have a few numbers, 570,000. So where's your decimal place? My decimal place is over here. You will jump 1, 2, 3, 4, 5. You jump 5 times. So this is 5.7. And because we jump 5 times, it's 10 to the power 5. Now, a very easy way to check if your standard form is correct is by just press the calculator and check if your numbers before and after is exactly the same. If they are different, you probably made a mistake somewhere. Now, if you have a small number over here, the 0 is here. Because on the left-hand side, this is 0, right? It's not a non-zero digit. So we have to move to the right-hand side. 1, 2, 3, 4. Now, because we move to the right, we actually have -4. Okay? So just take note, if you move to the left, it's a positive number. If you move to the right, it's a negative number over here. So you end up with 2.3 times 10 to the power -4. How do you check this? Same thing, you press your calculator to check. To double check. Because sometimes our brain itself might not be working well. When we mental sum, sometimes we make careless mistakes, especially if we keep doing a lot of calculations. Sometimes your brain gets tired. I want to use calculator to double check as well. Okay? Now, it won't always be so simple and straightforward. So sometimes they will give you this. If you already have the 10 to the power 6 over here, the first thing we do is this number on the left. This is not in the standard form format. So 1, 2, 3. We jump 3 times to the left. So it is +3. So we plus a 3, it becomes a 9, and then your unit will be at the back. That's all. Okay? So let's do some examples to make things clearer to us. So first thing, 54 cm. Is this SI unit? Sorry, not SI unit. Is this standard form? First thing, this is a double digit, right? We don't do that. We'll jump 1 time. So this is 5.4 times 10 to the power 1. But 10 to the power 1, we don't actually write 10 to the power 1. We just write 10. So this is 5.4 times 10 cm. That's all. So next one, 4, 1, 2, 0, 1, 2, 3. Not sure if you noticed, but there's actually a blank every 3 digits, 1, 2, 3, 1, 2, 3. So you can do this as well to make it clearer. Otherwise, sometimes when you write all your words, it's a little bit messy. So 1, 2, 3, 4, 5, 6. So 6 jumps to the left, so it's a positive 6. So 4.12 times 10 power of 6 meters. So you can see, right, sometimes if you have a very, very, very large number with a lot of zeros, it's very hard for you to write because sometimes you might forget how many zeros you wrote. So by writing this 4.12 10 to the power of 6, it's a way to actually shorten it so that it's easier for markers or readers to see. So when they are reading any kind of like science papers and all that. Okay. The next, 42 times 10 to the power of minus 7 kg. First thing, 42 is not right. We jump over here. This is 4.2 times 10 to the power of minus 7. And because we jump one time to the right, we plus 1. Okay, so we end up with 4.2 times 10 to the power of minus 6 kg. Okay. 6. This is where it gets more complicated. 0.154 megawatts. Okay. There's a few ways we can do it first, because if you actually notice, they want to express your final answer in watts, not megawatts. Okay, so mega, capital M, is actually, because we have the prefix, we will times, correct? So times 10 to the power of 6 watts. So remember, this is your mega. So next, 0.154, this is not standard form, right? So we need to jump 1 times to your right. So what actually happens is 1.54 times 10 to the power of 6. Because we jump to the right, we will minus 1. So you actually get 1.54 times 10 to the power of 5 watts over here. Okay. Actually, one way you can check if your values are actually correct is you press this in your calculator, and then you press this in your calculator. The number that you get should be the same. If your numbers are different, most likely you plus or you minus 1 wrongly or you plus 1 wrongly. So you need to be careful which side is which. Okay. Then last but not least, let's write your part E over here, 134 microampere. So like I said, the units at the back, you don't need to care so much about them. But just leave them as they are. So 134, because I have the prefix, I will times. And this is micro, is a small. So we'll leave it as it is. Next one, 1, 2, we jump 2 times to your left. So 1.34 times 10 to the power of minus 6 plus 2. We end up with 1.34 times 10 to the power of minus 4 amperes. That's all. Okay, so you can see all the different steps. So just be careful. It's very important that you write everything down nicely, unless you are super duper confident or until you're like constantly giving me A1s. Please do all your steps properly so that you can solve what they are respectively. Don't just assume. Please be careful of all this. And feel free to always go back to memorize this table. But ultimately, as you move on to your upper set or to your set 2, set 3, set 4, make sure you know what all of these are. Try your best to come up with a table or use like flashcards to actually try to make yourself more familiar with what they are so that you can actually remember this, because this will be part of a lot of your different calculations. So this is like the basics. So they will build upon this part. They will use it in other chapters, like for your speed, for your forces. Some of them will include all of this, like density or volume. So you need to be able to know how to convert from cm to meters, meters to cm, and so on and so forth. Okay. So next one, where you guys will need to pay attention. Okay, this is what we call the careless mistake zone. Okay, this part is very, very easy to make careless mistakes. So you need to first identify area. Okay, this is your area A. So if your area is 50 cm squared, what this is the saying is 50 times 1 cm squared. And what is 1 cm? 1 cm square is 1 cm, the whole thing, squared. So far, so good. So what does that mean? It means 50 times bracket. Now, from 1 cm, you want to change it to meters. What do we do? Because I have the prefix, I will times 10 power minus 2. And the whole thing is going to be squared. So if you press this in your calculator itself, you actually end up with 0.0050 meters squared. Okay, because a lot of students, when they do this step, they just divide by 100. Okay, so try to avoid this because a lot of them will just times 10 to minus 2 one time. But don't forget, there's a square. So anytime you have a square, you will whenever you times and divide accordingly. You need to square the entire thing. In the cm, you need to square the entire c. You cannot just square, or you cannot just times one time. You need to square it twice. Okay. So let's see this one as well. This one is actually the opposite. You have 20 meters square. It's the same as 20 times 1 meter square is 20 times 1 meter, the whole thing squared. You will repeat the same step over here, but now I don't have the prefix. I will minus 2 cm and the whole thing squared. So if you press this in your calculator itself, you will end up with 1, 2, 3, 4. So you actually end up with 200,000. So to make things clearer, 1, 2, 3. Just take note, you want to leave a space in between so that it's easier for us to see the marker, I mean. So you can see over here, meter square, we will have a square over here as well. Square, 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 the whole thing square. Okay, now why do we take out the 20 in the front and the 50 at the front? Because these 20 and 50 are just the amount. What we want to change is the unit itself. So we don't include your 20 inside your squared brackets. Because if you put it inside, it has a different meaning altogether. So we don't do that. We will separate them separately. Okay? Now, just be careful whether it is square or cube. Because if you have a cube, there will be volume. Okay? So if your volume was, hang on, how much did they use? 202 million. 1, 2, 3, 1, 2, 3. This is cm cube. You want to change to meter cube. First thing, 1, 2, 3, 1, 2, 3 times 1 cm cube. 1, 2, 3, 1, 2, 3, bracket 1 cm cube. You will times, because I have the prefix, I have the c inside, right? I will times minus 2, and this is my meter, and I'll cube it. So you press this in your calculator, you end up with 2 meter cube. Okay, so it's a bit hard to show you what it means because 1 cm is actually very, very small, right? You can use your ruler to measure it, but 1 meter is very big. So if 1 meter, 1 meter, 1 meter, you have a cube. That's the side of 1 meter, 1 meter, 1 meter is much, much, much bigger than a cube with a side of 1 cm. So you can see over here, every time you have a square and cube, please stop and double check. Okay, if you don't stop and double check, especially for all your square and cube, you're gonna make a careless mistake. It's very, very easy to make a careless mistake, especially at lower sec where you guys are still unfamiliar with the squares and cubes. Just be very, very careful. If you have a cm square or cm cube, you want to be very, very careful when you do your conversions. Okay. Now, if you notice over here, the first one now, speed is 36 kilometers per hour. What does that mean? It means 36 kilometers over 1 hour. Because 36 divided by 1 is still 36, right? So this is just 36 kilometers per hour. So if you want to do your conversion, we'll actually do them separately. Your numerator, if you want to change them to SI units, first thing, you want to change to meters. I have the prefix times 3 meters. 1 hour. 1 hour you want to change to second. First thing, 1 hour is 60 minutes and each minute is 60 seconds. So you just need to press your calculator inside here. You will end up with 10 meters per second. Okay, so do them separately. So you need to be mindful of that. Next, this one over here, the second one, second example, density is 5 grams per cm cube. So it is grams over 1 cm cube. Now, do you see the cube here? This is where you want to stop and be very, very careful about it. So 5 grams, you want to change it to kg. We don't have the prefix on the left-hand side here. We will divide by 3. And below 1 cm cube, because it is 1 cm cube, you will times minus 2 meter cube. So you press this in your calculator itself, you will end up with 5,000. Okay, make sure that you have your cube in your calculation, in your calculator. If you don't press the calculator properly, you end up with a much smaller number instead. Okay, so just be careful about this. So you can actually repeat your steps. So let me just move this to the other side so that I can do some and show you the calculation. Now, first one, word example. So if you want to try it, you can pause and try it first. First one, 18 meters per second. We will change it to 18 meter over 1 second. So next, they want kilometers and hours. So what do? We don't have the prefix on your left-hand side. We will divide by 3. Seconds to hours. 1 second, we don't know. We'll actually do the opposite for just now what we did. So we actually divide by 60 2 times. So you press this in your calculator itself. 18 divided by 10 to the power 3. 1 divided by 3, you end up with 64.8 kilometers per hour. Okay, so this is for your first one. For your second one over here, 57.6 kilometers per hour. Do the same. Kilometers over 1 hour. 57.6. Because I have the prefix, I'll times 3 meters. 1 hour, I'll times 60 times 60 seconds. So press this in your calculator itself. You end up with 16 meters per second. Okay, then next one, let's try 13.6 grams per cm cube. This one, you can actually try it as well. 13.6 grams, 1 cm cube. You do the same step. 13.6, you want to change to kg. I don't have the prefix, I will divide. 1 cm cube, I want to change to meter cube. I put the bracket cube outside. 1, I have it, minus 2. So you end up with 13600 kg per meter cube. Okay, and last but not least, you have your 1.5. 1.5 Newton per cm square. First thing, they want us to change to Newton per meter square, right? So 1.5 Newton, I don't need to change because it's already Newtons already. The only thing you need to change is the one below. Because I have a square, I want to change to meters, I will times because I have the prefix minus 2. So if you press this, you end up with 1.5. Now let me check. 1.5 over bracket 1 times 10 to the power minus 2 close bracket square. So you end up with 15,000 Newton per meter square. Okay. So with that, this is all your calculation part. So please be careful about all your different calculations and do spend some time to actually go back and memorize all your table itself. But if you are not, if your school doesn't require to, you can just memorize the one in yellow. Okay, for the rest, most of the time, either your school will give it to you in the question, they'll tell you the value, or if your school learns it, they'll probably ask you to memorize the whole thing. Okay, so just be careful. Just remember these values. Okay, if you want to use hundred and thousands itself, you can use the one over here. But basically, for the bigger numbers, you cannot just use hundred and thousands. You need to be familiar with what the values are. Okay, so please spend some time to maybe retry some of the calculation again. Take note of all the different steps, like how I break it down. Only when you are very, 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 very good at it, straightforward, straight A1s, no problem with this, then you skip steps. If not, please write all your steps clearly, because these are all worth method marks. Okay, you want to tell your teacher, I know what's going on, this is what I'm doing, that's why I have this answer. So if you do all your steps correctly, you should be able to get all your answers correctly and properly. So for very, very big numbers, make sure to use your calculator to double check. Please don't trust your mental sum. Then for this standard forms, make sure that your first digit cannot be 0 or a double digit. Okay, it must be a single digit, and then the rest behind, if it's very, very long, round it up to 3 senior figures where there's three numbers in front, and the fourth number should be great. If it's greater than 5, we will include +1 here to your third number. If it's less than 5, we will just remain as it is. Then don't forget, we put a 3SF at the back. Okay, so if there's nothing else, that is actually it for today. Please pay attention to your squares and cubes. Okay.